5x plus 5y is equal to 15. Now I am going to find the points on the axis, coordinate axis. X is equal to 0, then we'll get y value is 3. And y is equal to 0, we are going to get x value is 5. So here the points are, here one is 0, 3, another one is 5, 0. In the same way, we have to take another line. Another line is, another inequality is 5x plus 2y. 5x plus 2y is equal to 10. Here also same, students, like take x is equal to 0, y value is 5, and y is equal to 0, value is. From this, what are the points we are getting here? 0, 5 and 2, 0. There. First, I am going to draw these two lines in xy plane. So the highest value on x-axis is 5, y-axis is 5. And so
Sir, it's not little up, sir.
the feasible region are bounded by the constraints of 3x plus 5 are lesser than or equal to 50. Given constraint I have written. After that, I am taking the equations. These are the not inequalities, equations. Optimum solution means either it is a minimum solution or maximum solution. It is minimized or maximized. Feasible region always bounded region. Infeasible region always unbounded region. Feasible region lies between within the corner points. The corner points can decide the at the corner points only we'll get the maximum value or minimum value. Okay, ma'am? So this is x-axis, y-axis, this is origin, 0, 0. Now, first one, what are the points 0, 3, 5, 0? 0, 3, here, 5, 0 will be here. So I'm going to identify those points. This point I'm taking as A value is 5, 0. B point, this is a point B I'm taking as B, 0, 3. Now I'm going to intersect, I'm going to draw the right. This is the line, and whose equation is, what is the equation of this line? Line equation is first one. 3x plus 5y is equal to 15. Next, another line. 5x plus 2y is equal to 10. The points on the coordinate axis are 2, 0, 0, 5. 2, 0. Two, 0 will be here. This point you can take as C, 2, 0, and 0, 5. D, point D is 0, 5. Okay, join them. Okay, right. This line equation is 5x plus 2y. Yeah, 5x plus 2y is equal to 10. Fine. Next, coming to inequality. Okay, these are the graphs of the given line. Okay, these are the linear equations. Now I'm going to take one by one. First, 3x plus 5y is lesser than 15 or greater than 15 in the, okay, lesser than 15. I'm going to find the solution region for inequality. Okay, what is the solution region for this 3x plus 5y is lesser than, yes students? Yeah, 3x plus 5y is this line, right? Yeah. This is 3x plus 5y is equal to 15. It's lesser than 15. Now, again, I'm going to choose one point on the uh, first part and second part. This line can divide it into plane again, two parts. First one, second one. Now, when I take 0, comma 0, if 3 into 0 plus 5 into 0 lesser than 15 or not? Yeah, 0 lesser than 15, so that 0, comma 0 is one of the solution region for the given inequality. So the solution region for the inequality 3x plus, yeah, this is the solution region. This is the solution region for 3x plus 5 lesser than 15. In the same way, next one. Next one is 5x plus 2y. What is 5x plus 2y? Lesser than 10. 5x plus 2y is lesser than 10. Again, substitute 0, comma 0 here. 5 into 0 plus 2 into 0 is lesser than 10, means 0 is lesser than 10. Yes, here also 0, comma 0 is the solution region, one of the solution of that. So now if I draw the, no need to draw, you can particularly you can draw like that. You may draw 2 here. Right. Now coming to next, we have drawn that line, graph of the line, as well as we found the solution region for the inequalities. Next, restrictions are there, non-negative restriction. That is x greater than or equal to 0. What is the shaded region of x greater than or equal to 0? Yes, students? X greater than or equal to 0 means, sorry, it is right, this is the solution region. This is solution region. Fine. Then this is x greater than or equal to 0. Then what about y greater than or equal to 0? Y greater than or equal to 0 is above x-axis. Above x-axis. No. Any light shaded region? Okay, you can shade the region above. Okay, students. Then this is about y greater than r equal to 0. Then finally, what will you conclude here? Yes, students, what is the required region here? The required region common to all the regions is this. This region. Got it, students? So this is the required region. Okay, ma'am? So here it has some corner points. What are the corner points here? The corner points are, one is origin, that is 0 comma 0. Second one is, let us take, this is a, this is 2 comma 0, and this point is there. This is, we need to find, we have to solve, this is b, I want to take b is 0 comma 3. Next I want to solve, this is like you can take as c. C point are required to find by solving the equations, not inequalities, equation. What are the equation? One is 3x plus 5y, 3x plus 5y is equal to 15. Another one is 5x plus 2y is equal to 10. 10. Now solve these two equations. Like when I multiply here, the equation, okay, what shall I do? Shall I multiply here 2, here multiply with 5. When I multiply with 2 here, we will get
Sir, we can't hear you.
So can you show the beginning of the slide, sir? Sir, can you scroll down, sir? Sir, your voice is not audible, sir.
Can you hear me now properly?
Sir.
Yes, sir.
Okay, okay. So is it clear, Amma? Like how to identify the feasible region? Yes or no? This is feasible region. Now solve this both the equations like 5x plus 2y is equal to 10 and 3x plus 5y is equal to 15. I multiplied 2, I multiplied with 5 here. So we get equation 6x plus 10y is equal to 30 and 25x, 10y is equal to 50. Subtract both the equation, 10y, 10y cancel. Minus 19x is equal to minus 20. So x value is 20 by 19. Y value is 45 by 19. So the point C is here. X value is 20 by 19, 45 by 19. Okay. Therefore, what about the corner points? Look at here. The corner points I have written clear in the first one. The value of the corner points of the feasible regions are. Now we have to write the corner points. What are the corner points in here? O, A, B, C. Corner points of feasible region is like OABC. Then take the corner points. Corner points. Next, Z value. What is the Z value over here? Z value is the question. 5x plus 3y. 5x plus 3y. What are the corner points? One is 0, comma 0.
Sir, can you scroll up, sir?
Yeah, you
Sir,
can
can you
note it down.
scroll down, sir?
All of you note it down.
Okay, sir.
Now, what are the 0, comma 0, 2, comma 0, 3, 0, comma 3? comma 0, B is 0 comma 3, and C is 20 by 19, 45 by 19. Yes, students, all of you. Find Z value. And 0 comma 0, Z value is 0. And 2 comma 0, Z value is 10. 0 comma 3 is 9. Then at 20 by 19, 45 by 19,
235 by 19.
235 by 19. So among all these values, what is the value is highest?
235 by 19.
So this is maximum. The Z value is maximum at this point is called point of extreme point. Z is maximum is 20 by 19, 45 by 19. So the maximum value is, what about the maximum value? The maximum value is clearly 235 by 19. At what point? The point of extreme theorem. This is called the point of extreme theorem or extreme point theorem. So they don't want, here we don't want the point, but we should find the values properly, that maximum value. Clear, students? So all the questions will do like this only. All questions. All of you, you can do the remaining questions. All are easy. Okay. Show that the minimum of Z occurs at more than 2 points. More than 2 points means at 2 points we'll get the same value. The 2 points we are going to get the same value. See here, for example, here, one of the, see here, at 2 different points we got multiple optimal solution means maximum at 2 different points. One is 15 comma 15, one is 0 comma 20. At these 2 points, okay, it is having maximum. Okay, it may be minimum, it may be maximum, but in this question, it has maximum. So after taking the, you have to finally write the maximum value of Z or the feasible region occur at 2 corner points, and it is 180 each case. But in this question, the feasible region occur maximum at the point, only one point, that is 20 by 19, 45 by 19. At the point, sorry, the maximum value is 235 by 19. Like that you have to write. The maximum value of Z on the feasible region occurs at only one point for us. Okay. Here also what they have done. Here they do not return like inequalities. They do not taken as x plus 3y is equal to 60 like that. Directly they have drawn the graph. To understanding purpose, I have written. I have taken that equal to 0 equations. Okay, students. Now, all of you do this. Question number 7 or 8. Which one will do, Amma? Here we are going to draw the 3 lines. 1, 2, 3. Here also 3. 1, 2, 3. And 1, 2, 3. Okay, here you can observe that x greater than or equal to 3. Still previous question, like x comma y greater than or equal to 0, but here x must be greater than or equal to 3. Means we are going to get the region. This when I take x is equal to the region, we are going to get like this here after 3 hours. Shall I do that question number 9? Your wish, any question? Here it is greater than, less than, less than. Less than, greater than means the area feasible region is lies between these 3 lines. Like here, when you observe here, these are the unbounded examples for unbounded, because you know it will be extend this region, will get infinity. We don't have in the syllabus. Okay. Yeah, 3 lines are there. 1, 2, 3. The area between these 3 lines. Like in the same way, here also, question number 7, 8, 9, 10. Okay, in all this, only 2 equations are given. Only 2 equations. Okay, students, already it is 1:55. You can try to do this, and in tomorrow class, we'll do this, any one of the question. After that, only few questions are there in exercise 2, word problems. They'll give the data according to the data, like this, they'll give the data. So according to this data, we have to form the equations, like we have to take the objective function, we have to form the linear inequalities. Yeah, this is the objective function according to the data. We'll get some constraints and non-negative restrictions. Then after that, we have to same, like we have to draw the graph of the line, we can find the solution region of inequalities. Then you can find the feasible region, will get a corner points. After that, at each corner point, you have to find the z value, whatever it is maximum. So that is the optimum value. Okay, like that word problem will give. In that few questions are belongs to bounded region. Those questions and all we will do. Word problems. Okay, ma? Okay, students, will wind up the class.